All right, today we're diving into a really fascinating and frankly pretty serious sleep condition. It's one where that solid wall between your dream world and the real world just completely crumbles. We're talking about REM sleep behavior disorder. So let's get into what happens when dreams decide to break free. So just think about this for a second. What if your most intense, action-filled dreams weren't just movies playing in your head? What if you could actually, physically, live them out? Every punch, every kick, every single night, and you wouldn't even know it was happening. You know, this might sound like something out of a sci-fi movie, but for some people, this is their nightly reality. And that reality can be incredibly intense, even violent. We're talking about real physical actions like punching the air, kicking, shouting things out, swearing, sometimes even leaping right out of bed. The dreams that get acted out are often these high-stakes scenarios, being chased, fighting off an attacker, or defending a loved one. The key thing is, the physical movements perfectly match what's happening in the dream. So the big question is, how on earth is this even possible? Well, to really get a handle on this disorder, we first have to understand this incredible safety feature that our brain has. It's a switch that's supposed to flip every single night. We need to figure out what happens when that switch breaks. And the whole thing boils down to this one crucial concept, REM atonia. Okay, so REM, or rapid eye movement sleep, that's the stage where we have our most vivid, story-like dreams. To keep us safe, our brain does something brilliant. It paralyzes our muscles. This atonia, which literally means a lack of muscle tone, is our built-in safety mechanism to stop us from, running a marathon in our sleep. And this paralysis command, it comes from a very specific part of our brain's mission control. Deep down in the brainstem, there are two little structures, the pons and the medulla. During REM sleep, their job is to send these powerful stand-down signals all the way down the spinal cord. These signals tell your motor neurons to just take a break, effectively shutting down muscle movement and keeping you perfectly still while your mind is off on an adventure. And this chart, this lays it out perfectly. It shows the core difference. On the left, that's normal REM sleep. The protective paralysis switch is flipped on. Your body stays still, you've got REM atonia. But on the right, with RBD, that whole system has failed. The switch is off, and your body is now free to act out those vivid dreams. So if you take away one thing, it's this. RBD is, at its heart, REM sleep without atonia. That's the whole ballgame. Now, with all this drama, you might think diagnosing it would be a piece of cake. But telling RBD apart from other things that go bump in the night, that actually takes a pretty specific scientific investigation. So let's look at how doctors get to a surefire diagnosis. Look, a doctor can't just rely on stories from a spouse, no matter how wild they are. To be absolutely certain, there is a gold standard test. It's an overnight sleep study, and its official name is polysomnography. This is, without a doubt, the only way to definitively diagnose RBD. So when someone's in the sleep lab, what are the technicians looking for exactly? They're hunting for one specific piece of evidence. They use something called electromyography, or EMG, which measures muscle activity. And when they see on the monitors that a person is clearly in REM sleep, they can tell by the brain waves and eye movements, but their muscles, especially under the chin, are still firing away instead of being quiet. That's it. That is the smoking gun. Documented REM sleep without atonia. That's what confirms the diagnosis. And this right here is exactly why that sleep study is so vital. You have to rule out other things. Take a look at this chart. Sleepwalking or night terrors, they happen in a totally different stage, non-REM sleep. It's usually earlier in the night, and the person is often really confused and can't remember a dream. But RBD, that happens in REM sleep, so it's later in the night, and often the person can wake up and tell you exactly what dream they were just acting out. It's a completely different event happening in the brain. Okay, we're now getting to what may be the single most important part of this whole explainer. Because you see, a diagnosis of RBD is about so much more than just managing strange nighttime behaviors. It is very often a profound early warning sign of something much, much deeper going on. Just take a look at this number for a second. Over 80%. That is a huge figure. What studies have shown is that the vast majority of people who are diagnosed with what's called idiopathic RBD, which just means it doesn't have a known cause at the time, over 80% of them will eventually develop a specific kind of neurodegenerative disease. And here's the connection. RBD has been found to be one of the strongest predictors we have for a group of brain diseases called synucleinopathies. Now, these are conditions all caused by the abnormal buildup of a protein in the brain called alpha-synuclein.
And get this, those same circuits in the brainstem, the pons and the medulla, that fail in RBD, they are often the very first places to be affected by this protein buildup. It's like the first domino to fall.
And we're not talking about rare conditions here. This list includes some very well-known diseases: Parkinson's disease, dementia with Lewy bodies, and multiple system atrophy. What's truly incredible is that for so many people, the dream enacting behaviors of RBD can show up years, sometimes even decades, before any of the classic motor or cognitive symptoms of these other diseases appear. Now, I know that last bit of information is heavy. It's a lot to take in, but it is so important for understanding long-term health. In the here and now, though, there are very clear, very practical things that can be done to manage the disorder and, most importantly, to keep everyone safe.
Job number one, without a doubt, is creating a safe space to sleep. Because the behaviors can be so unpredictable and sometimes violent, the risk of injury is very, very real, both for the person with RBD and their bed partner. This means taking simple but critical precautions: patting the floor next to the bed, moving sharp objects or clutter away from the bedside, and in some cases, it might even mean sleeping in separate beds just to prevent any accidental injuries.
Now, when it comes to medical treatment, there are two main players. The first choice these days is often melatonin, usually at pretty high doses. It can be very effective, and the big plus is that it has a much better side effect profile. Then there's clonazepam. It's been used for a long time, and it definitely works, but it can cause some real problems, like making people drowsy during the day or affecting their balance, which is especially risky for older adults who might already be at risk for a fall.
Okay, so once someone has a diagnosis and a management plan is in place, what comes next? Well, the focus really shifts to being vigilant and committing to long-term monitoring.
Because of that incredibly strong link to neurodegeneration we talked about, getting an RBD diagnosis means that regular, long-term check-ins with a neurologist are absolutely essential. This stops being just a sleep problem. It becomes a potential window into a person's future brain health, and that window needs to be watched very, very closely.
And that monitoring isn't just about what happens at night. Doctors and patients have to be on the lookout for other really subtle, early clues that a synucleinopathy might be developing. We're talking about things like a fading sense of smell, ongoing constipation, maybe very slight changes in how someone moves or walks, or small shifts in their thinking. These are all potential signs that the underlying disease process might be moving forward. So, we'll end with this thought. REM sleep behavior disorder really shows us that what happens in the dead of night can be this incredibly powerful clue about our long-term health, a kind of warning signal broadcast directly from our dreaming brain. And it really makes you wonder, doesn't it? If our dreams can reveal a secret this profound about our future, what other critical messages about our health are we just sleeping through?